Let us discuss vector multiplication. There are two types of vector multiplication. In the first type, two vectors are multiplied and the result is a scalar. That is called a dot product. In the case of dot product, we multiply the magnitudes of two vector and correspondingly the cosine of angle between them is then multiplied with both the magnitudes. So for example, if we have a vector u having components u1, u2, u3 in e1, e2, e3 Cartesian space, and another vector v having component v1, v2, v3, the dot product of two vectors u and v will result in u1, v1 plus u2, v2 plus u3, v3. That means to say that if we write the vector in its full form, that is u1 e1 plus u2 e2 plus u3 e3, and dot product it with v1 e1 plus v2 e2 plus v3 e3, we will have two scenarios. Either we will have a particular unit vector which is in the direction of the same unit vector, or we would have a particular unit vector which is orthogonal to the direction of another unit vector. So as we have said that two vectors dot product is equal to the magnitude of two vectors times the angle between them. So if the two vectors are in the same direction and they happen to be a unit vector, then the dot product is 1. If they are orthogonal, and that means to say that the angle between them is 90-degree, so the dot product would be 0. So once we open this up, we will get the required product. Now there is another type of multiplication which is called cross product, and the result of this multiplication is a vector. So unlike the dot product, we have a vector resulting from this type of multiplication. So it is written normally that a vector w would be equal to u cross v. We can construct a vector w that is perpendicular to the two vectors u and v, which are, say, two sides of a parallelogram on a plane in a space. So these two can be two sides of a parallelogram within a space, and w is the outward drawn normal to the parallelogram. So right hand screw rule is used if w is right-handed, if the vector in the given order assume the same sort of orientation as the thumb, index finger, and middle finger of the right hand when these are held, as in this figure. So we may also say that if u is rotated into the direction of v through the angle theta, then w advances in the same direction as a right-handed screw, which if turned in the same way as a screw. So the cross product is normally worked out using a determinant. So what we do is we write a 3 by 3 matrix in a determinant form. We have got the unit vectors written as e1, e2, e3, and then the corresponding components of u and v written like that. If we open it up, we will have e1 times the crossing out the corresponding rows and columns of e1, we get u2, u3, v2, v3, then minus, and the second unit vector times the 2 by 2 determinant, which is crossing out this time the row and column corresponding to E2. So we are left with U1, V1, U3, V3. And similarly, in the case of E3, again crossing out the rows and columns corresponding to E3, and we are left with U1, U2, V1, V2. So this is vector multiplication. Vector multiplication is different from scalar multiplication. That's why we have two different types of vector multiplication.